Everybody can see and hear and everything?
Yeah, I can see and hear everything.
Thank you. All right. So for the circuit shown below, find the frequency in radians per second at which the impedance is purely resistive. Find the value of ZAB at that frequency of A, and then repeat if all three elements are in parallel. So I'm actually going to do part C first because I like part C much better. Because when I do part C, if all three elements are in parallel, I have 625 nanofarads, 4 kiloohms, and 5 henries, I know that the frequency at which it is purely resistive is the resonant frequency. And the resonant frequency for in parallel or in series is 1 over the square root of LC, or 1 over the square root of 5 times 625 times 10 to the negative 9, or five hundred and 65 radians per second. And at that frequency, it is purely resistive, and so Z would equal just the value of my resistance, which would be 4,000 ohms. That's part C. Part A, we can't do that because this is neither series nor parallel. And so what we need to do is to combine them. So we've got 5 4 625. So my two that are in parallel, that will be 4,000 times 625 times 10 to the negative 9. No, never mind. Hold on, I haven't changed them to phasors yet. So this would be, this is J omega L. So it is 4,000 times J omega L over 4,000 plus J omega L. And then I'm going to add that to my inductor. Wait, sorry, that's in it. I'm getting tired. It's a capacitor, so that's minus J over omega C. Of course it would be the capacitor that's in parallel. So it's going to be 4,000 times minus J over omega C over 4,000 plus minus J over omega C. And then I'm going to take that and I'll add that to my inductor, which is plus J omega L. So this becomes, if I multiply by omega C over omega C, becomes minus J 4,000 over 4,000 omega C minus J plus J omega L. Now here's another reason why you have to know how to multiply by the conjugate. because here, these aren't numbers. I can't plug it into the calculator. Even though I could get the C and the L, the omega, I don't know. So minus J 4,000 over 4,000 omega C minus J times 4,000 omega C plus J over 4,000 omega C plus J omega L. So that is minus 4,000 squared J omega C. And then J times J is negative 1. So then that would be plus 4,000 over, and then in my denominator I get 4,000 squared omega squared C squared plus 1 plus J omega L. And so this is minus 4,000 squared J omega C over 4,000 squared omega squared C squared plus 1 plus 4,000 over 4,000 squared omega squared C squared plus 1 plus J omega L. Now to find the part where this is purely real, I need the parts with the J to equal 0. So I need minus 4,000 squared omega C over 4,000 squared omega squared C squared plus 1 plus omega L to equal 0. And that would get me.
I think you forget the J and the WL.
No,
You removed it in my mind.
Yep, they both had a J, and so this is the imaginary part without the J.
Yeah.
So then I get 4,000 squared omega C over 4,000 squared omega squared C squared plus 1 equals omega L. 4,000 squared omega C equals 4,000 squared omega cubed C squared L plus omega L. Just multiplying both sides by that. You can cancel one omega out of everything. And then you get 4,000 squared C minus L over 4,000 squared C squared L equals omega squared. And if I didn't make any mistakes, which is not likely, then you would then solve for omega and you would get 400 after you plugged in for C. Now, do I think you'd have one like this? No. Do I think you'd have one like part C? Yes. Part C was if they were all in parallel, because then that's easy.
I have a question.
Yeah.
Could you scroll down a little bit to where we had 3 terms for the, this part. So could you explain how we're able to get rid of the second term again?
Yeah, because we're looking for the part where the imaginary part is equal to 0. So the imaginary part is the part that has a J. So the real part, I don't care about it. I'm not like saying it doesn't exist. I just am only interested in where the imaginary part equals 0.
Okay, that's why we separated it from the...
From the real part. Right.
Okay.
And that's also why the J isn't in here, because I don't need the J to equal 0. I need that part to equal 0.
Right, okay, thank you.
You're welcome. Other questions?
I have a question.
Yeah.
When you go, after you move the WL to the other side, and you move, that part, why do you become?
I multiplied both sides by 4,000 squared omega squared c squared plus 1. So on this side it canceled, and on this side 4,000 squared omega squared c squared plus 1. I distributed the omega L to this. So I got 4,000 squared omega cubed c squared L plus omega L. And then if, in fact, I did this right, and you got omega equals 400 radians per second, if you plugged that in to our impedance, our total impedance, so like if you go back and figure out what it is with the real part, so you don't need to plug it in, you just would plug it into the real part, because the imaginary part would be 0. So if you plug 400 into just the real part, you end up getting 2 kiloohms. So you don't get just like when we had it in parallel, we said our impedance would be 4 kiloohms. Because it's not in series or parallel, it's not 4. It ends up being 2. Okay, other questions?
I'm sorry, what was, if you plug it in?
You get 2 kiloohms. Or you're supposed to. I haven't actually, at that point, I can't do that without making mistakes. All right, and I believe there's one more, and let's do that last one. And I'm going to do this last one on the same recording. Okay, the interconnection described in problem 2 is connected across the terminals of a voltage source that is generating 470 cosine. So this is, I'm moving on to problem 8. So we've got our voltage source is 470 cosine 6,000 T volts. What is the maximum amplitude of the current in the capacitor? So if you go back and look at problem 2, in problem 2, we got y'all would be so mad if you saw like the Circuits 1 test review at this point. You would say, oh, really? Okay. For problem 2, we got what did we get for the impedance at 8?
80 plus J14.
Yes, 80 plus J14. We got Z equaled 80 plus J14 for the impedance. And we had a circuit that looked like, trying to remember what we had. We had a resistor in parallel with a capacitor. And that whole thing was in series with a resistor and an inductor. And the question is, what is voltage across the capacitor. Okay, so we know the total voltage is 470 angle 0. And did we compute the impedance of these two in parallel when we did problem 2? That was on the other computer. It was oh, did I really? Okay. I've got this.
I have 50 minus 50 J.
Say it again.
I have 50 minus 50 J.
15,
50.
50. 50 minus J50. Oh yeah, that would be right. That seems right. Yes. Okay. And then I can't find my work. Okay. And what did I say we're looking for? The voltage? Okay, and then what was the impedance of the inductor? Was it J64, and the other resistor was 30? 30. Okay, so all we need to do to find the voltage across the inductor is to do voltage division. And so, didn't I ask that when we did this problem? Anyway, so it would be 470 times J64 over J64 plus 30 plus 50 minus J50.
Why are we doing across the inductor again? Is that just what the question asked?
Oh, because the problem said capacitor. So I don't know. No, we should not be doing across the inductor. In case I wanted to do it across the inductor, this is what I would do. But across the capacitor, I would do 470 times 8 minus J50 over 8 minus J50 plus 30 plus J64, because since the capacitor and the resistor are in parallel, they have the same voltage. So I don't have to do them separately. So the voltage across the capacitor is the same as the resistor that it's in parallel with. And I'm supposed to have this answer here somewhere, but I don't seem to have it.
And where are you getting an 8 minus J50 in?
I'm misreading my handwriting. It's supposed to be 50 minus J50. Does that answer? Does that fix that? And then that is something, and my calculator is on the other side, and I think I've just worn myself out. So I think I can't do any more. I think I'm at the very end of my ability to do anything. So thank you all so much for coming. I appreciate it, and I'm going to stop here.
No, thank you. Oh, I'm going to assume we're allowed to use to like put into formula sheet our unit conversions, right? Not units, like the micro, kilo.
I don't know that for a fact.
Okay.
I would imagine, but I can't say for a fact. Okay, Zoom people, thank you so much for coming. Oh, you're welcome. Thank you so much for coming, and I'm gonna sign off. Thank you. Set it down. I appreciate everybody. Before y'all leave, could y'all make a sign-in sheet? Because I'm like here, like the day that everybody comes, I don't have record of people being here.
Do you have a piece of paper?
Yes.
I don't know if I could. You remember that?
I need your name and your email address.